Because students have so much trouble with word problems, let's think about doing a couple of more on just maximizing and minimizing, working with those quadratic equations. Here we know that a guided missile, we're getting fancy here, is propelled from the origin of a coordinate system, whatever that means, with the x-axis along the ground and the y-axis acting as the vertical. Okay? Find the object's maximum height if the trajectory is given by y equals 400 minus 16x squared. Good news, they gave you the equation. Bad news, there's a lot of other words that go with it, right? Okay, well, better news, that equation is a quadratic. So we know that if I'm trying to find the max or min anything, what point am I interested in?
Vertex.
The vertex. And this happens to be an upward or a downward parabola?
Upward.
Be careful, look at it really close. What's in front of the x squared? A negative. So it is a downward parabola. So whatever it is, it's downward. So we are talking about a maximum point there. So we kind of know that going in. We're going to take the equation y equals 400 minus 16x squared. And I'm going to rewrite it as y equals negative 16x squared plus 0x plus 400. I'm going to write it in general form, showing the A, the B, and the C. If I don't do that, I will make a lot of mistakes. I will confuse B for C and C for B and all of that when it's not written out for me. So I have to put it in order. First the A's, then the B's, then the C's. If you're missing one, put a 0 there to hold its spot. Now I'm going to find the vertex. The x value of the vertex is going to be equal to the opposite of B, which is 0, over 2 times A, which is negative 32, which is just 0. 0 what?
0 for, it's like vertical.
Well, we're assuming that it's feet, but it really doesn't tell us, does it? So we don't know. It's 0 some distance. Feet, meters. Okay, that's its horizontal distance, right? You'll understand that?
Like along the ground.
Yeah, that's horizontal. The y value of the vertex is equal to what? Negative 16, 0 squared, plus 0 times 0, plus 400. What's the y value of the vertex? 400 something. So there's your vertex, 0, 400. And we can assume feet. It may not be feet. Maybe it's kilometers. Maybe it's meters. We don't know what it is. They didn't tell us, but it's some distance. And that's vertical. Which one is considered height? Horizontal or vertical? Vertical. So what's the answer?
400.
400 units of distance, whatever it is. So you have to choose there. You find the x and the y. You have to decide, what are they asking you? They were asking you to find the maximum height. Well, height is vertical. And since they said that the y variable represented the vertical, that's what we have to use as that answer. For our final problem, let's look at this example. A rancher wants to enclose a rectangular but partitioned corral with 1,800 feet of fencing. What dimensions of the corral would enclose the largest possible area? So let's talk about what we're looking for. We need to find the dimensions that would enclose the largest possible area. Also, we need to find the maximum area. In order to even start this, we need to get a good drawing. We weren't given the equation, so we're going to have to find one on our own. So first off, we know it's a rectangle. Furthermore, we know it's a partitioned rectangle. We don't really know if it's partitioned straight down the middle or not, but we can just, kind of put that partition anywhere we want. So let's put it right here. So basically, we have two different sizes going on here. We have these 3 lengths of fencing that are the same size, and then we have these 2 longer ones. Let's call the 3 shorter ones X. Now we need to know what we have left over to use on the longer ones. Well, we have 2 sides to cover. We started with 1,800 feet of fencing, but we've already used up 3x of that. So now we're down to 1800 minus 3x. But I have to split that. That's the remaining portion, 1800 minus 3x. And that has to be split among the two sides equally because it's a rectangle. So if I split that equally, half of that is 900 minus 1.5x. So I'm going to let each one of these be 900 minus 1.5x. And if you take a minute to add up those five sides, you will see that it totals back to 1800. 3x is here, minus the 3x is here, gives me 0x, and the 900 plus the 900 gives me 1800. So that's a good representation of what I have available to use here. Now let's turn our attention to what we're going to find. We want the largest possible areas. We want the maximum area. So I'm going to need an area equation. So my area equation is going to be the length of the total rectangle by the total width. So my area equation is x times 900 minus 1.5x. Notice that even though there's an extra piece of fencing in the middle, it doesn't affect our area significantly, and we don't take it into account. So area equals 900x minus 1.5x squared. And writing that in general form, we know that the area is negative 1.5x squared plus 900x plus 0 for our c value. Anytime you want to maximize or minimize a situation that is a quadratic, you're looking for the vertex. We've talked about that over and over. So this answer is going to have something to do with my vertex. So let's go ahead and find that. We know that the x value of our vertex is equal to the opposite of b divided by 2 times a, which in this case is 2 times negative 1.5, or just negative 3. So the x value of my vertex is equal to 300. We need to talk about the units. We were told 1,800 feet of fencing. So I know that the x value here is 300 feet of fencing. And that's going to turn out to be what I should let this x be right here. Furthermore, the y value of my vertex is given by substituting 300 back into x for the equation that I found. So we have negative 1.5 times x squared plus 900 times x plus the 0. So let's calculate that really quickly. Negative 1.5 times 300 squared plus 900 times 300. That comes down to 135,000. So the maximum area is 135,000 square feet. Now, just because we found the vertex doesn't mean we've answered what we were asked to find. So let's go back for a minute. The first thing I was asked to find were the dimensions. Well, I definitely know one of the dimensions. I know that x, which I'm going to use as the width here, that x is equal to 300 feet, because that's the x value of the vertex that will provide the maximum area. But the length of that is whatever 900 minus 1.5 times that x is. So let's calculate that for a minute. 900 minus 1.5 times 300 gives us 450 feet. So let's see if that makes sense. If I let this value right here be 300, so this is 300, this is 300, and this is 300. These two sides are 450. If I add up all 5 of those numbers, that should be my total amount of fencing. Let's see what that gives us. 450 plus 450 is 900, plus 300 is 1,200, plus another 300 is 1,500, and then the final 300 comes to 1,800. So sure enough, the perimeter of that fencing does come out to be 1,800, which is what I needed in this problem. Now let's talk about the second question that was asked of us. Aside from the dimensions, we were asked to find the maximum area. And we believe, based on the vertex, the maximum area was 135,000 square feet. But let's make sure that that makes sense. Maximum area is 135,000 square feet. Let's look back at what we've drawn up there. The length times the width here is 450 times 300. So 450 times 300. Let's see if that comes out to be 135,000. Sure enough, it does. So that's a good way to check yourself at the end. You can go back to the drawing. So while the drawings are difficult because you're not given the equation, you have to find them, they're also nice because you can check it better than you can with an equation that you were just given. And that wraps up section 3.2, quadratic functions.